In the previous lecture we have seen all the operations related to vertex creation or modification of location of vertices. In this lecture we are going to see all the operations which are available on the edge in Gambit. What are different operations that we can do in Gambit? So let's start. So the first operation is related to the creating different kind of edges. So the first kind of edge that you can create is the straight edge between the two vertices. So what it does is it creates one or more straight edges which are connecting the different vertices which you have given. We can create more than one edge at a time, and depending on how you are going to do the selection, the sense of the edge will be decided. So sense of the edge will be from start vertex to the end vertex, and that sense will be used in many like meshing operations, where if you are doing a clustering, it will decide if the clustering is need to be done at the start, near the start point or the end point. It is also during the splitting operation and all. So the sense of the edge is used in many operations in Gambit. So let's have a look at how to create a straight edge. So for that purpose, again I am going to use the graph paper for creating a grid for creating vertices. So I will say I want a grid in xy plane. The value of x, minimum value of x should be -10, maximum should be 1, and increment should be 1. Maximum should be 10 and increment should be 1. Update the list. Similarly y, minimum is -10, maximum is 10 and 1. Update the list and then say apply. Make sure that visibility is on. Apply. So I got the graph paper, and then I can say control and right click. I can create the vertices. So I will create some different vertices which is needed for the straight edge. For example, then say visibility off and just say apply. Now I can create the edge. So geometry creation operation and then edge creation. The first is nothing but create edges. So there are different methods which we are going to have a look at it. What are the different methods by which you can create the straight edge? So I'll go to straight edge. Then what type of edge we want? Let's say I want a real edge using these two vertices. So this is the start vertex and this is the end vertex. I'll say apply. Now I got the edge, and the shape of the edge is a straight edge in between. Now we can always go and check their you can say it's a direction. So if we go to meshing, edge meshing operation, and if you select this, if you see the sense, whenever you select the edge for meshing, it always shows you the sense by the arrow. So it is definitely we have selected this as a start point and this as an end point, so that is why this will be a sense. Now if I do some clustering, this will decide whether the clustering will be need to be done at the start or at the end. So if the ratio is more than 1, the clustering will be done at the start, near the start, and if the ratio is less than 1, the clustering will be done near the end. So there you can say direction of this vertex will be, or direction of the edge will be used. Now I have created only one edge. At that time I have given only two vertices. Now I can create multiple edges at a time, and I will select vertices in a proper sequence the way I want the edges. So again I will go into a pick mode, select this vertex, select this vertex, select this vertex, and then this vertex, and just say apply. If you see, it has created edge 1, 2, 3, and the sense is from this vertex to this vertex, this to this, and this to this. Similarly I can select this vertex, and this vertex. So this edge is created. Now if you see, all these edges are connected to each other. What do I mean by connected is they are sharing a common vertex in between. So this is the way the straight edges will be created. You can create real as well as virtual edge. So let's have a look at another operation which is virtual. So as I said, like if you have selected multiple vertices, multiple edges will be created. So if this is the first vertex, vertex 1, vertex 2, and vertex 3, if you see, I mean, if you have selected the vertices in this way, vertex 1 and vertex 2 will be edge 1, and vertex 2 and vertex 3 will be edge 2, and the sense will be vertex 1 to 2 and vertex 2 to 3. So that will be a sense of the edge, or the direction of the edge. Similarly, same vertices if you have selected, but the sequence of selection is different. You have selected vertex 2 first, and then 1, and then 3. Vertex 2 to 1 will be one edge, and the direction will be 2 to 1, and vertex 1 to 3 will be another edge, and the direction will be 1 to 3. So that is the meaning of the direction. It is always start vertex, the first vertex you have selected, to the last vertex that you have selected. That is the direction of edge. Similarly, as I said, you can create a virtual edge also between the between the two vertices. So for creating a virtual edge, what you have to do is you have to give the vertex, two vertices in between which the virtual edge will be created. And if you want, you can give a host also. If you give a host, the shape of the edge will be same of the as that of a shape of your host that you have selected. And if you don't give a host for a virtual entity, the shape of the edge will be always a straight line. So that is the virtual edge that you can create between the two edges, two vertices. So this is the command associated with the creating a straight edge between the vertices. This is the syntax, and this is the simple command: edge create straight between vertex 1 and vertex 2. These are the labels of the vertices. Virtual on face dot 1. It means I am creating a virtual edge, and the host of that virtual edge is face dot 1. That is the meaning of this particular command. You can always create a circular arc. That is the second method of creating edge. The shape of the edge is a circular in nature. There are three methods available. One is 3-point method, another is 2-point method, and third is radius, angle, center, and plane. So let's have a look at different methods one by one. So the first method is create a circular arc by giving a center vertex and two end point vertices. So we need to give center vertex, two end point vertices, and we also need to give major or a minor arc, because even if I give center and 2 point, for example in this case center this and 2 point, let's say this is the point and this is the point. If I give these points, like let's say this is the center point I am giving, this is the first point I am giving, and this is the second point I am giving. In both the cases, if you see, I can always create this kind of arc, or I can create this kind of arc. So we have to give information to Gambit which kind of arc that you want to create. One is called as major arc, and other is called as minor arc. So that is the information that we have to give along with the center as well as two end point vertices. And definitely arc cannot be created if the vertices are collinear. It means if they are in the same line, I cannot create the arc, because in that case Gambit cannot decide which one is major and which one is minor. So that is the reason why we cannot create an arc for collinear vertices. So, and similarly, like if the points that you are given, if the distance between the points from the center, let's say you are given one point A and B, if the distance between center and point B, if it is same as that of distance between center and point A, definitely it will create a circular arc or circular edge. But if the distance between the two endpoints that you have selected, if they are not same from the center, then definitely a spiral arc will be created. So that is the behavior of the circular arc if depending on the distance from the centers. So this is the first method, as I said, create circular arc by 3 points. So let's go and create the circular arc by 3 points. So right click here, arc, and my method is 3-point method, in which I am going to give the center vertex. For example, this is the center vertex, and I am going to give this and this as the endpoint vertices. And I am interested in, let's say, the major arc, and apply. If you see, what I am getting is, in this case, I guess in this case I am getting the circular arc, or because they are equidistant, are they? We can always check it. Go to summary. This edge, this is 4.2126, and summary this is 5. They are not same. If you see here in transcript window, it also shows us the length of the edge. So 4.2426 and 5. So they are not equidistant. So definitely this is not a circular arc. This is like elliptical arc. So again, go to arc, select 3-point method, give some center value. Let's say this is the center, and let's say this and this is the end point. So what I got is I got the arc. I got the arc which is a major arc. Now I'll activate the minor arc. Similarly, I'll select same this point as the center and these 2 points as the end vertices. So I got the minor arc. So this is the way this 3-point method works. The second method of creating vertices is 3 vertices on the arc. You specify 3 vertices on the arc. It constructs the edge from the first specified vertex through the second specified vertex to the third specified vertex. I'll tell the meaning of this. First and third vertex will act as the end point of the vertex, and second vertex will be only used for creation purpose. I mean, this is not connected to this edge. It means if I select, for example, if I select this as the first vertex, this as the second vertex, and this is the third vertex, what Gambit will assure you is whatever the arc which is going to be created, that arc will pass through these 3 points. And once the arc is created, the use of the second vertex is done. That is only used for construction purpose. Only vertex 1 and vertex 3 will be topologically connected to this particular edge. They will be end points of this edge. The second vertex will not be the part of the edge. It is just used to create the edge. So that is the meaning of only used for construction purpose. So this is the way vertex 1, vertex 2 and vertex 3 vertices on the arc, and it will fit the arc in between. Similarly, if you say if the same vertices, but if the sequence of selecting vertices is different, let us say this is vertex 1, the first vertex I have selected, the second vertex I have selected is vertex 3, and the third vertex. In this case, this arc is created. So this is the effect of specifying the vertices. For example, go to 3-point method and select the vertices. Let's say I am going to select for example this vertex, and this vertex. I will say apply. If you see, the kind of edge I got is this, but I am going to select the same vertices, but now this time I am selecting this vertex, and this vertex. I will say apply. If you see, then another you can say edge is created. So I will just for example, if I am selecting this vertex, and then this vertex, if you see, this edge is created. So this edge is passing through the vertices which are selected 1, 2 and 3. So that is the this is the first vertex which I have selected, this is the second vertex which I have selected, and this is the third vertex which I have selected. So what it is doing is it is passing this arc through these 3 points. So that is nothing but 3-point arc. It always this is nothing but the 3-point arc. The last method is nothing but the third method which is there, which is nothing but you provide a radius, you provide angle. If needed, you can also provide the center and the plane. So once you are given this, it will create a circular arc always. I mean, in this case, it always creates circular arc. So what it needs is it needs the radius of the arc, it needs the start and the end angle of the arc, and it needs center vertex. If you want to give a center vertex, if not specified, it will be always the center of the coordinate system, and you have to also give the plane in which the arc lies. So radius and start angle, end angle defines the size of the arc, and center vertex defines the global location of the arc. For example, what it does is it creates the vertex edge in this way. You have to give the center point, you have to give the start angle, and you have to give the end angle or stop angle, and you have to also give the radius. What it will do is it will create the circular arc by using this center. If the center is not provided, the center will be always the global centroid. You have to also provide the plane, because I can always create by using the same by using the center point vertex and the angle, I can always fit the plane in different planes. For example, let me delete all the edges. Pick all. I don't want to delete vertices, so apply. Yeah, all the edges. And now let me create the circular arc. So arc, and then circular arc, let's say radius is 3, start angle is start angle is 0, end angle is let's say 360, because I want a complete circle and I want that in xy plane. Apply. If you see, what you got is you got a complete circle in xy plane, and the center of that circle is this. But now if I only change the plane, apply, if you see, I got the circle in this plane, or if I change the plane, I got the circle in this plane. So this is the meaning of it. Means by using the same definition, I can always create the circle in different planes. So we have to also specify the plane. Now as this is created at the center, we have to always do a move operation to take it to the proper location, but we can always create the circle at different locations. So now I will activate center, and I will say center should be this. So with same options, radius 3, 0, and start angle is 0, end angle is 360, and let's say I want it in xy plane. Apply. If you see, the circle is created at the center. So if you want to create, for example, a cylinder attached to a cube, we can always do that. So first is I will create a cube of 10 by 10 by 10, or if you want to create a cube of different size, you go here, volume creation, say brick. I want to create a brick, let's say of size 5 by 5 by 5. If I don't give remaining size, it will be same as the size which you have given. I'll say apply. So I got a cube. Now I can always create the vertex at the center. If you remember, there is operation on at centroid. I'll say I want at face centroid. Let's say which face I want, at this face, for example. So I got a vertex at the centroid, and now I want to create, let's say, a cylinder. So I'll say I want to create an arc. The radius of that is, let's say, 1. Start angle is 0, end angle is 360, and I want that into YZ plane. So I'll activate YZ and apply. If you see, I got a circle. I got a circle here, and now I can always extrude that circle and create, or first is I will create the face out of it. So create a wireframe. Let's say I'll create a face. I got the face, and then I will use a split face operation. Split a face, this face, with, because they have to be connected to each other, this face, and apply. Now I got two faces, and now I can sweep that face in a x direction. So this face, vector, define, positive x, magnitude, let's say 10, apply and apply. Now I got a cylinder. So this is the way we can use this, creating a circle on the face using the point which is created at the center. We can always use this operation for creating these kind of geometries. So this is the third method by which you can create a circular arc in Gambit. So as I said, like, you can give the start vertex or the plane in which the arc is created. You can always create the full circle. It means the circle, it will not be a circular arc, but it will be always a full circle. There are two methods available. One is the 3-point method, again center and 2 points on the circle, and another is the 3-point points on the circle. So but in this case, it is always going to create the circular edge. For example, if I go and select 3 points, I will select 3 points. So I will delete all the volumes without lower topology. I got only faces. I will delete all the faces without lower topology. I got only edges. I will delete all the edges without lower topology. I got the vertices. Let's say isometric, so that I can visualize these vertices properly. Fine. Now I can go to circle. I want a full circle. let's say the center of that should be this, and let's say the end point should be this, and for example this. So what I got is I got a circle, I got a full circle. So center this point and this point, if you see this point is always this is only a part of this edge, this is only for a construction purpose, center point is also a construction purpose. So the points which you have selected, the two end points which you have selected, those points must be equidistant from the center that you have selected. In that case only the circle will be created, else it will fail that those are not at equidistance. For example, if I select this as the center and these, yeah, they are also equidistant, so I will select different points. So this as the center and this and these 2 points as the end points. So if you see they are not equidistant, so definitely it will give the points selected do not share a common radius because they are not at the same distance. So this is the way the circle can be created by a center point and 2 points on the circle. The second method is 3 points. You just give 3 points, it will always fit the circle. For example, I will say this point, and this point. I want a circle, it always gives us the circle. Or I can say this point, and this point. I can always fit a circle which is passing through the 3 points. So it will automatically find out the center and it will automatically find out the radius of the circle. So that is the 3 point circle, a full circular arc that you can create. So these are the methods by which we can create the edges, straight edge, circular arc, or a full circle. Let's have a look at different other methods of creating edges. So we can create an elliptical arc. It creates an edge in the shape of the elliptical arc. What it needs for ellipse, we need the center vertex, we need a major vertex, and we need on edge vertex, which will decide what is this minor axis, and also we need to give the start point and the or start angle and the end angle of the arc which is going to be created, the elliptical arc which is going to be created. It will create arc in this way. We need to give the center vertex, we need to give the major vertex, and we need to give the on edge vertex. So in that case it will create the elliptical arc. We have to give the start angle as well as the end angle. For example, if I want to create the elliptical arc in using these vertices, so what I will do, go to elliptical arc, then we have to give the center vertex. For example, let's say this is the center vertex, and let's say this is the major vertex, and let's say this is the let's say this is the center vertex, then this is the major vertex, then this is the on edge vertex, and the start angle and end angle is 0. Start angle is 0, end angle is 360. Apply, it will give me the elliptical arc. So the way the selection is done, if you are in pick mode, the selection is very easy. Go to pick mode, select the center vertex. Now I want to go for the next selection. So accept this selection, which is nothing but right click. So right click, it will go to the next selection. If you see this is yellow in color, so now I will give major axis, again right click. Now it is asking me on edge vertex, I will give this, and then if I again say right click, it is apply. So the right click is apply as well as do the next, go for a next selection. So that is nothing but right click. So this is the way you can create the elliptical arc using 3 points. If I give the angle which is different, so for example, this is the center vertex, this is the major vertex, this is on edge vertex, and then let's say I am going to give this as 180 degree and then apply. So it has given me arc which is from major to 180 degree passing through this on edge vertex. So this is the elliptical arc that you can create. You can also create a conic arc. It means a arc in the shape of the parabola, ellipse, or hyperbola. So it needs the start vertex. This is the start vertex. It needs the shoulder vertex. This is the shoulder vertex, which is the peak point of that particular arc, and then we have to give the end vertex. So it will create the arc depending on what is the density parameter which you have given, or what is the shape parameter which you have given, rho. If the rho is equal to 0.5, it is a parabolic arc. If it is rho is less than 0.5, it is elliptical arc, and if the rho is more than 0.5, it is hyperbolic arc. For example, in this case, as I said, elliptical, parabolic or hyperbolic arc we can create. So if rho is in between 0.01 to 0.5, less than 0.5, it is elliptical. If it is equal to 0.5, parabolic, or if it is greater than 0.5 to 0.99, if it is in this range, it is hyperbolic arc. So it creates the arc in this way. So again I will say undo. So again I will go to conic arc. So conic arc, I have to give the start point. Let's say this is the start point, and let's say this is the shoulder point. Let's say this is the shoulder point, and this is the, let's say, end point. And right now my parameter is 0.5, so it is parabola. I will say apply. So it has created a parabola. Similarly, I can say this is the start point, this is the shoulder point, and this is the end point. And now this is the start point, right click, shoulder point, right click, end point, and now I am going to give parameter as 0. For example 8. So it is hyperbola. I will say apply. So it has created a hyperbola in between. Similarly, I can always say 0.1, which is less than 0.5. So this is the start point, this is the start point, right click, shoulder point, right click, end point, and it is elliptical arc. So it has given me elliptical arc. So this is the three ways by which you can create a conic arc between the vertices you have selected. The next method of creating arc, which is also called as fillet arc, it means if you have two edges which are intersecting or which are approaching for intersection, non-parallel edges basically, then you can create a fillet arc between the two edges that you have selected. So what we have to do is we have to select the edge, two edges, and we have to give the fillet radius. So depending on how selection is done, depending on whether the trim option is active or not, the behavior of this fillet arc will be decided. For example, let me create some proper vertices for creating edges. So again, I already said what is minimum maximum, so I will just activate visibility and then apply, and then have a look at the front view of it. So this is the graph paper which I got. Let me create some edges. So I will select this vertex, control right click, again control right click, and let's say control right click. So I got the vertices, visibility should be off. Then I will create a straight edge in between, go to straight edge, these two vertices and these two vertices. Fine. So these edges are not intersecting. Now let's say imagine that I want to put a fillet arc in between. So I will go here and say fillet arc. I will select this edge, let's say this edge, then I will select this edge, and the radius of these two should be, let's say 0.8, I guess, because the distance is 1. Apply, or I will say 1. So this edge and 1. What is the distance between these two edges? So we have to find out the distance between two edges. So straight edge, the distance between, let's say this, and the distance between these two edges, summarize this edge. So distance is 2. So definitely the fillet radius should be more than 1. So I will go to fillet, this edge and this edge, and let's say fillet radius is 1.5. Apply. So I got the edge, I got this fillet edge. Now I will just deactivate this trim. So I will select this edge and then this edge, and I'll say apply. If you see, what it has done is it has created these edges. So this is one fillet edge which is created, original edges are there. So depending on where you are doing the selection, the fillet will be decided, or the trim options, which edges will be deleted, that will be decided. So let's have a look at those things. So for example, like if these are the two edges, and then if you do the selection, because here if I can fit a circle of particular radius at this end also, as well excuse me, as well as at this end also. So depending on where you are doing the selection, if the selection is near to one point, end point, the fillet will be created there. If the selection is near to this end point, the fillet will be created here. If the selection is near this end point, the fillet will be created here. So whenever you select the edge, for example, whenever I am going to select this edge, here it will tell you the u value, and it also, whenever you select the edge, it also shows you the sense. So if this point of selection is less than 0.5, then the fillet will be created at the start point. If it is more than 0.5, the fillet will be created at the end point. Similarly, here also it is more than, here also it is, for example, this edge it is more than 0.5, and this edge it is more than 0.5. This edge, right click, this edge more than 0.5 and apply. So what it says is, as you are doing a selection here, the fillet will be created here, but the radius of the fillet which you have given is 1, so there is no possibility of fitting a circle of radius 1 near this end point. So if I increase the radius, let's say if I say radius is equal to 4 and say apply, I'll deactivate trim edges, and radius should be, let's say, 3. So it has created a fillet circle somewhere here. So depending on what is the radius you have given, depending on what is the gap between these two points, two end points, depending on that the fillet will be, whether the fillet creation is successful or not, that will be decided. So whenever in this particular slide it is explained that whenever you do a selection near the end points, like if it is below 0.5, it is at the start point, the fillet is at the start point. If it is more than 0.5, the fillet is at the end point. Similarly, if the edges are intersecting edges, the location of the selection point with respect to edge of the end points, and the location of the selection point with respect to the point of intersection between the edges. So this will matter if the fillet is going to be created or not. For example, in this case, let me create some vertices for creating those kind of edges. So again, use the same graph paper. Now let me create these two intersecting edges. For example, this vertex and this vertex, this vertex and this vertex, and then go to straight edge. I'll create this edge, and then I will create this edge. So these two are intersecting edges. Now I can create a fillet between these two edge, fillet, and then I will say, okay, this edge is the first edge, this edge is the second edge, and the fillet radius is, let's say, 1, apply. So it has created this. I will just deactivate this trim, again this edge and this edge, fillet radius. So if you see, the radius is created somewhere here. Now if I select again this edge, but it is near to this, and again this edge, because it is near to this, the fillet is created here. Again if I say this edge, I will deactivate trim, this edge near to this edge near to this, the fillet is created somewhere here. Similarly, I will say this is the first edge, this as the second edge, the fillet is created here. So depending on how you are doing selection, the fillet will be decided. So in this case, if you do a selection, for example, this point and this point selection, if it is this point and this point selection, if you say it is near to this end, it is near to this end, definitely the fillet is going to be created something like this. Similarly, if I select this point and this point, this point is near to this end, this point is near to this end, so definitely fillet is created here. Similarly, if I select this point and this point, again the fillet is created here. But if I select this point which is near to this and this point which is near to this, the fillet is created somewhere here. So depending on what is the fillet radius that you are providing, the fillet location will be decided. So what it always does is, it always keeps the minor arc of the circle. Imagine that you have two edges and in between you are fitting a radius circle of radius r. Now there is a possibility that you will get this particular arc or you will get this particular arc. But what Gambit does is always creates the minor arc, means the smaller arc which is there. Similarly, in this case, if this is the arc and if this is the arc which is going to be created after fitting the tangential circle, it will delete this particular arc, which is a major arc, and it will keep only the minor arc. So again, if you activate the trim edges, which is most of the time which is the case because we don't want to have the original edges. So if you activate trim edges, depending on where the arc is created, the location of the edges which will be kept, that will be decided. So what I will do is I will select this edge, the point of selection is here, then I will select this edge, the point of selection is here. It means what Gambit will do is, wherever you are doing selection, Gambit will try to keep that segment. It means once the fillet is created, imagine that one fillet arc is created and then it is going to do the splitting of these edges. So wherever I am going to do the selection, Gambit will try to keep that particular segment. So if I say apply, if you remember, I had done selection here, I had done selection here. So what Gambit has done is, first is it has trimmed these edges at these points, and then it has deleted this segment of the edge and it has deleted this segment of the edge. So that is what Gambit will do. Gambit will always try to keep the segments in which you have done selection. Similarly, if I select for example this, and then if I select this, if you say I selected this segment and then this segment, so Gambit will definitely try to keep those segments. So this is the way the trim operation will work. So again, if I select, for example, if I select this part of the edge, this is the, let's say, first edge, and this, let's say, this is the second edge, then definitely the fillet is created here. So depending on if you have activated trim operation or not, and where you are doing selection, Gambit will do a proper trim operation, or it will put a proper fillet edge. So in this case, again, all these dotted lines are nothing but the lines which will be deleted. So if you have done selection, let's say these are the two edges which are intersecting with each other. If you have done selection here, and let's say this is the fillet which is going to be created, you imagine that there is a circle which will be tangential to these two edges. So wherever the tangency points are there, they will act as a split points. So it will split this edge into two edges by using this point, and then it will delete this part of the edge. Similarly, it will split this edge using this tangential point, and it will delete this part because you have done a selection here. Similarly, if you have done selection here and here, if you see, again this is the fillet which is going to be created. As you have done selection here, it will try to keep this particular edge. For example, again if I done selection somewhere, like if I done selection, one selection is, let's say, here, and another selection is, let's say, here. If you see, it has kept these particular edges. Or if I done one selection here, and if I done another selection somewhere here, it will keep this particular edge. So please remember that Gambit is going to keep the edges where you have done a selection. It will try to keep that segment of the edge. For example, in this case, if I selected this and this is the fillet arc which is going to be created. At the tangency point, they are going to be splitted, and it will keep this segment and this segment, and then these dotted segments will be deleted. So this is nothing but trim edge. So how to do the selection? So give the first edge. You can always do the selection here, which is pick list form. You can select edge 1, but it will be difficult to do that. So generally I prefer to go for pick mode. So go to pick mode, select this edge. So it will definitely specify what is the u value. You can always change that u value. You can say 0.5 or you can say whatever is needed for doing split operation. So select this edge, then right click, go for next selection, select this edge, and then right click is nothing but apply. So this is the way this particular create real fillet arc will work. So the next method is creating a NURBS arc, NURBS curve. NURBS is nothing but non-uniform rational B-spline. So it will create the 3-degree NURBS curve passing through the given points. We call it as a free curve. It means the shape will be a free curve kind of a shape, and it applies the natural boundary condition at the both the end. It means the curve second derivative, the curvature should be, second derivative of the curve is nothing but curvature. The curvature should be 0 at the end points. It means there will be a straight line at the ends. The type of the curves depends on the type of the endpoints that you have selected. It needs 2 or more vertices, and it needs the method by which the edge will be constructed. For example, I will delete some of the, or maybe I will delete everything and I will create new vertices. So again, activate the graph paper, apply, fit to screen, and then control right click. I want some points for vertex or edge creation. So I will select this, and let's say I got the points. Now I will deactivate the graph paper, apply. Now go to edge, and this is nothing but create the NURBS. So go to NURBS. There are two methods, interpolate, approximate. We will see those. Now select the vertices. The sequence of selecting vertices is very important in this case. So this is the first vertex, second vertex, third vertex, fourth vertex, fifth vertex, sixth vertex, and seventh vertex. And then I will say apply. If you see, this is the NURBS which is created. This is only a single edge. This is the start point and this is the end point. So if you see here carefully, here the curvature of this edge is 0. It means this edge is not this kind of circle at the end, or this edge is not a circle at the end, or this is not curved at the end. Definitely in between it is curved. So this is the third degree NURBS fitted with the boundary condition.